Geographic Information Systems, or GIS, are powerful tools that allow us to visualize and analyze geographic data. Imagine a map that not only shows where things are, but also provides information about those locations. That's the essence of GIS. It helps us understand patterns, relationships, and trends in our environment. In the realm of environmental monitoring, GIS plays a crucial role. It enables us to track changes in forests, monitor wildlife populations, assess pollution levels, and much more. By integrating various data sources such as satellite imagery, aerial photographs, and field observations, GIS provides a comprehensive view of our planet's health. The ability of GIS to analyze data over time is particularly valuable. By comparing maps and data from different periods, we can identify areas experiencing deforestation, habitat loss, or other environmental issues. This information is essential for informed decision-making and effective conservation efforts. Whether it's protecting endangered species, managing natural resources, or mitigating the impacts of climate change, GIS empowers us with the knowledge to make informed decisions for a more sustainable future. At deforestation, the clearing of forests for other land uses, is a pressing environmental issue with far-reaching consequences. Forests, often called the lungs of our planet, play a vital role in regulating the climate, absorbing carbon dioxide, and providing habitats for countless species. Cross River State, located in southeastern Nigeria, boasts some of the most biodiverse rainforests in Africa. These forests are home to a wide array of plants and animals, many of which are found nowhere else on Earth. However, deforestation poses a significant threat to this rich ecosystem. The conversion of forests to farmland, logging activities, and urban expansion have led to a concerning rate of deforestation in Cross River State. This loss of forest cover has severe implications for the region's biodiversity, climate, and the livelihoods of local communities who depend on forest resources. Understanding the drivers and consequences of deforestation is crucial for developing effective strategies to protect Cross River State's remaining forests and ensure the well-being of its people and wildlife. Tracking deforestation requires a systematic approach, and GIS provides the framework for doing so effectively. Here's a step-by-step guide to using GIS for tracking deforestation. First, gather data like satellite imagery and forest cover maps. Sources like Landsat and Google Earth are valuable. Next, pre-process the images to correct errors. Then, classify land cover types using GIS software. Perform change detection to identify forest loss. Map and quantify deforestation areas. Finally, assess accuracy with ground truth data. This process helps track deforestation and understand its drivers. Effective deforestation tracking relies on robust tools and reliable data sources. Essential components include GIS software like ArcGIS, QGIS, and Google Earth Engine. High-resolution satellite imagery from Landsat, Sentinel, and Planet Labs is crucial. Aerial photographs from drones or aircraft offer detailed views. Field data from surveys or GPS tracking validates remote sensing analyses. These tools and data sources create reliable deforestation maps for conservation. Section 5. Challenges and Solutions in GIS-Based Deforestation Tracking. While GIS offers powerful capabilities for deforestation tracking, several challenges can arise during the process. Data availability and accessibility. Access to high-quality satellite imagery, particularly for historical periods, can be limited or costly. Data sharing agreements and open access platforms are crucial for overcoming this challenge. Cloud cover. Clouds can obscure satellite images, making it difficult to obtain clear views of forested areas. Using radar imagery, which can penetrate clouds, or employing image compositing techniques can help mitigate this issue. Image interpretation and classification accuracy. Distinguishing between different land cover types, such as forests and plantations, can be challenging based on satellite imagery alone. Incorporating ancillary data, such as elevation or texture information, can improve classification accuracy. Ground truth data collection. Collecting ground truth data in remote or inaccessible forested areas can be logistically challenging and expensive. Collaborations with local communities and the use of mobile data collection tools can facilitate this process. Addressing these challenges requires a combination of technological advancements, data sharing initiatives, and capacity building efforts. By working together, we can improve the accuracy and effectiveness of GIS-based deforestation tracking. Section 6. The future of deforestation. Tracking advancements and innovations. The field of deforestation tracking is constantly evolving, with new technologies and approaches emerging to enhance our capabilities. Artificial intelligence, or AI algorithms, are playing an increasingly important role in automating image analysis, improving classification accuracy, and detecting subtle changes in forest cover. Machine learning models can be trained to identify deforestation patterns with greater precision. Near real-time monitoring. Advances in satellite technology and data processing are enabling near real-time deforestation monitoring. This allows for rapid detection of forest loss, facilitating timely interventions and law enforcement efforts. Drone technology. Drones equipped with high-resolution cameras and sensors offer a cost-effective and flexible platform for monitoring deforestation at local scales. They can access remote areas and provide detailed imagery for analysis. Citizen science. Engaging the public in deforestation monitoring through citizen science initiatives can expand data collection efforts and raise awareness about the issue. Mobile apps and online platforms allow individuals to contribute observations and validate satellite imagery. These advancements and innovations are revolutionizing how we track deforestation, providing more timely, accurate, and actionable information for conservation efforts. Section 7. Community engagement and capacity building for sustainable forest management. While technology plays a vital role in deforestation tracking, it is equally important to engage local communities and build capacity for sustainable forest management. Community-based monitoring. Empowering local communities to participate in deforestation monitoring can provide valuable insights and enhance the sustainability of conservation efforts. Training programs on GIS, remote sensing, and data collection techniques can equip communities with the tools to monitor their forests. Knowledge sharing and collaboration. Facilitating knowledge exchange between scientists, government agencies, and local communities is crucial for effective forest management. Workshops, training sessions, and online platforms can foster collaboration and share best practices. Alternative livelihoods. Supporting alternative livelihood options that reduce pressure on forests, such as sustainable agriculture, ecotourism, or non-timber forest product harvesting, can contribute to long-term forest conservation. By integrating technological advancements with community engagement and capacity building, we can create a holistic approach to deforestation tracking and sustainable forest management. Section 8. Conclusion. GIS. A vital tool for combating deforestation. Deforestation is a complex issue with significant environmental and societal consequences. Geographic Information Systems, or GIS, have emerged as indispensable tools for tracking deforestation patterns, understanding the drivers of forest loss, and guiding conservation efforts. By integrating satellite imagery, aerial photographs, and ground truth data, GIS enables us to monitor changes in forest cover, quantify deforestation rates, and identify areas at risk. This information is crucial for informing policy decisions, targeting interventions, and evaluating the effectiveness of conservation programs. As technology continues to advance, we can expect even more sophisticated GIS applications for deforestation tracking, including the use of artificial intelligence, near real-time monitoring, and drone technology. However, technology alone is not enough. Addressing deforestation requires a multifaceted approach that includes community engagement, capacity building, and sustainable forest management practices. By combining technological advancements with local knowledge and collaborative efforts, we can effectively combat deforestation and preserve our planet's precious forests for generations to come.